Okay, we are on FRQ topic 2. I am making these videos on these FRQ topics during the summer, and I have a summer cold, so I apologize for my gravelly voice, my nasally voice, overly nasally voice, but you're just going to have to suffer through it. Okay, graphical analysis is our topic 2. All right, this is always on the AP exam. Okay, it's always there. Always no calculator. So just like the series question is always number 6. Okay, this one is not always number whatever, but it is always no calculator, so it'll be either 3, 4, or 5. Okay, this one is always common to the AB exam as well. So there are 3 FRQs that are common every year to the AB exam and the BC exam. So graphical analysis is one of them. Okay. All right. So sometimes you're given that a G or whatever is an integral involving f, and then you'll be given the graph of f, or you might just be given the graph of like f prime, and then all the questions will be about f. All right, so one of those two situations. So you're given a graph, and then you're given some information. Either it's the graph of a derivative, or they give you another function and they say that it is an integral involving that function. Okay? All right, and you use that information in a variety of ways, okay, all involving the function, either g or, f if this is an f prime graph, okay? All right, and I'm not going to read all these things to you, but it all is a graphical analysis, so it's all like relative mins maxes, increasing, decreasing, concavity, points of inflection, things like that, okay? You will likely also need to find values of the function. All right. So to find values of the function, you likely will either be given a value and then asked to find another value. This is all using the fundamental theorem of calculus. All right. So if you have to find a value of a function, you're going to be using the fundamental theorem of calculus. If you're given the derivative of the graph. If you're given that I'm making it sound really more complicated than it is. Once we get to some examples, you'll see. If you're given that g is this integral, then all you do is plug in to find like g of 2. You plug in 2 for x. Yeah? And then work it out. Work it out. So you're using the signed area under the curve. Anyway, okay. Let's not forget the second part of the fundamental theorem. The derivative of an integral. The derivative of an integral with boundaries. Okay? I make it this general one so that u and v could both be functions of x. All right? Derivative of a definite integral. Start at the top, take its derivative. Then plug that boundary in for t. So v prime f of v minus u prime f of u. Okay? All right. And then oftentimes in these, you need to find an absolute min or max, and you set up and complete the candidates test for that. All right, we're going to be doing the two most, let's see, what do I have here? I have here the one, I'm going to be doing 2019 and 2021. So let's take a look at 2019 first. Okay, pretty high, very high, KHS average, all right, that year, 2019. Continuous function f is defined on the closed interval, -6 to 5, -6 to 5. The graph only shows -2 to 5, but they're telling me that it is continuous and defined from -6 to 5. Okay, The graph shows a portion of the graph of f, consisting of 2 line segments and a quarter of a circle, centered at the point 5, 3. It is known that the point 3 minus square root of 5 is on the graph of f. So when x is 3, when x is 3, f is 3 minus the square root of 5. All right, part A. If the integral from negative 6 to 5 of f is 7, find the value of the integral negative 6 to negative 2 of f. Okay, well, in this one, the writers were asking, does this student know some of the properties of a definite integral? So for part A here, so go down to the box for A. The integral from negative 6 to 5, I'm going to set it up like this. I want the integral from negative 6 to negative 2. I can get the integral from negative 2 to 5. So I'm going to split this up into its 2 pieces, negative 6 to negative 2 plus negative 2 to 5. So I'm splitting that up. Okay. Now, I know that this is 7. They tell me that this integral is 7. This is the piece that I'm looking for. And I can find the value of this piece by signed area between the curve and the x-axis from negative 2 to 5. So signed area between the curve and the x-axis. So remember, the x-axis is always a boundary here. So this signed area, this signed area, and this signed area. That will be the value of the integral when I combine those signed areas, right? So let's take a look. This is half of a unit, but right here, this little piece right here is negative half of a unit. So they will cancel each other out. These 2 pieces over here will cancel each other out as well. And I'm left with this piece here. Okay. For this area, I have 1 full square, and I have half of 2 squares. So this is 1 plus 1. So that is 2. So down here, I'm going to write 2 for that. And now I'm going to come back up here. I want this area right here. And it is the remainder from this square when I remove that quarter of a circle. So the whole square is 9, because there are 9 blocks right there. The whole square is 9. And I'm going to subtract out this quarter of a circle with radius 3. So 9 minus 1/4 pi r squared, where r is 3. Okay, so now all I have to do is get this by itself. So I'm going to take, I'll just subtract 2, subtract 9, add this 1/4 pi times 3 squared, and that will be equal to this integral. Part A is done. Okay. Part B. Evaluate this integral. I'm going to write it down here. The integral from 3 to 5 of 2 f prime of x plus 4 dx. All right. I could split up this integral, spread it all out, but I think I'm just going to do this the quick way, because this is an f prime and I know what the antiderivative of f prime is. So this is equal to 2 f of x plus the antiderivative of 4 is 4x. Antiderivative from 3 to 5. So no u sub, no nothing was needed there, just an antiderivative. So this is 2 times f of 5. What is f of 5? F of 5 is 0. That's the graph of f. F of 5 is 0. Plus 4 times 5 minus 2 f of 3. F of 3. F of 3, that was that value that they gave us. 3 minus square root 5. Plus 4 times 3. And I'm done with part B. Okay, say stop. Part C. The function g is given by, g is this integral. Find the absolute maximum value of g on the interval. Well, absolute maximum value. So I know I'm using the candidates test. On g. So I'm going to set up the candidates test on g. Alright? And they tell me it's from -2 to 5. So part C. Candidates test. X is my independent variable. G of x is the function I'm finding the absolute maximum of. That is required, you guys. Do not leave this blank. Too often I see students leaving this blank. Don't leave it blank. Because otherwise these numbers that you put down here are meaningless. You are communicating what you are doing. So if you only put numbers down here, that's meaningless. So put them down there. -2 and 5 are our boundaries. And now I need to include anything that makes g prime 0, right? So those are my critical numbers. G prime is 0. I want g prime to be 0. And since we have an absolute max, I want it also to go from positive to negative. Correct? Okay, that's what I want. So what is g prime? They gave me g. What is g prime? Let me rewrite g down here for your sake on this video. I wouldn't normally rewrite this g down here, but okay. So what is g prime? This is that second part of the fundamental theorem, you guys. The second part of the fundamental theorem here. Because we're taking the derivative of an integral. Derivative of an integral. G is an integral. We want the derivative of an integral. So start at the top, take its derivative. The derivative of x is just 1, and then plug in x for t. F of x minus the derivative of the bottom. But the derivative of the bottom is 0. So it's like we have a minus 0 here. So g prime of x is just f of x. Okay, can I tell you something that's very annoying to me? It's very annoying to me when people tell me that g prime of x is f of t. No, it's not. That's a lie, okay? G prime of x cannot be f of t unless they're both constants, all right? And they're not. So don't tell me that g prime of x is f of t. We have to plug that in for t. That's part of the fundamental theorem. So plug it in, okay? So g prime of x is f of x. So up here I can say g prime of x is 0 and goes from positive to negative when f is 0 and goes from positive to negative. So f is 0 here, here, and here, and here. But where does it go from positive to negative? Only at negative 1. At x equals negative 1. So I need to put negative 1 over here on my candidates test. All right. Now I need to find all of these values. G at negative 2, G at 5, G at negative 1. So I go to my G function, and I'm going to plug in negative 2 for x first. If my boundaries are the same, this is just 0. So that is 0. Now I'm going to find g of 5. Integral negative 2 to 5. Okay, integral negative 2 to 5. Integral negative 2 to 5, that's our signed areas. That's what we found up here in part A. That was our yellow area, right? So it is this area right here. So that is, it's that value right there. So that is 11 minus 9 pi over 4. So 11 minus 9 pi over 4. And lastly, g of negative 1. Okay, from negative 2 to negative 1, that's that little area of positive 1/2. This is a positive 1/2, like that. Okay, and now we need to figure out what is the highest. What is the highest g value? I know a half is bigger than 0. My question is 11 minus 9 pi over 4 bigger than a half? Well, 9 over 4 is a little over 2, right? A little over 2, 2 1/4, times pi. 2 1/4 times pi, pi is 3.14, blah, blah, blah. That's going to be 6 point something. 11 minus 6 point something, or maybe even 7 point something. But it's still bigger than a half. So, the absolute maximum value of g is 11 minus 9 pi over 4. And that's what we were asked to find. Find the absolute maximum value of g. And that is the value of g. Sometimes be careful, because sometimes they will only ask for the x value. If they only ask for the x value, then you would of course give them the 5 here. Part D. Okay. Part D. Find the limit as x goes to 1 of this expression. Okay. As soon as I see a limit on an FRQ, I am assuming that we're going to use L'Hopital's rule. I am totally assuming that. So let's check it real quick. If I put 1 in for x up on top, I get 10, right? Minus 3 times f prime of 1. F prime of 1. Well, here's the graph of f. F prime of 1 would be this slope, which is 2, right? So I'm going to have 10 minus 3 times 2. That's not 0. So my assumption was that this would be a L'Hopital's rule. But it's not L'Hopital's rule. We're going to be one and done here. All we have to do is plug in that value. So I know that this numerator is 10 minus 3 times 2, the slope of f at 1. And on the bottom, I have f of x, f of 1, f of 1, f of 1 is 1. minus arctan of 1. Well, I know that arctan of 1 is pi over 4, but you know what? That's a safe stop spot. So if you put pi over 4 here, that would be fine, but if you leave it arctan of 1, that's fine too. So we're done with this problem, and let's take a look about how it was scored. So for part A, 1 point was given for splitting up this integral. So splitting up this integral, and they in their scoring guidelines, they rewrote this line, but I'm just going to write it as splits up the integral. Okay, 1 point for that. 1 point for, sorry about that, 1 point for, the value of this piece, the value of that piece. That was the area, the signed area under the curve. And then 1 point for the answer. So 3 points for that, part A. For part B, 1 point was for, what they called the fundamental theorem. Where did we use the fundamental theorem? Well, we used it when we plugged in the 3 and the 5 here, okay, to the antiderivative. 1 point was for the answer. Part C, let's see, part C was worth 3 points. 1 point was for saying that g prime of x is equal to f of x. That was 1 point. 1 point was for identifies x equals -1 as a candidate. And then 1 point was for the answer with justification. Okay, 3 points. So we've done 3, plus 2 is 5, plus 3 is 8. Clearly, part D is only worth 1 point because every FRQ here is worth 9 points. And this was just the answer. Okay, so that was for the problem from 2019. All right, next up, let's take a look at the problem from 2021. Okay, even when we had the 2020 exam, that was the COVID year where everything was online, even on that one they had a problem involving these questions. So it is always here, you guys, always. Okay, excuse me. 2021, a very high scoring problem for us, a very high global average on this problem. Very rarely do we see a global average of a 5 or above. Even the Texas average was super high. Okay, so a good problem for students this year. F is a continuous function defined from -4 to 6. The graph of F consists of 4 line segments, as shown on the right, and G is this integral. Okay, on what open intervals is the graph of G concave up? Well, I know that G is concave up when G double prime is positive, right? G is concave up when G double prime is positive. So for part A here, I know that G is this integral. So what is G prime? Okay, back to the second part of the fundamental theorem, because we're taking the derivative of an integral. So we start at the top and take the derivative, then plug that in for t, yeah? And then go to the bottom boundary. So I start at the top, take its derivative. The derivative of x is 1. Then plug x in for t, and I get f of x. Minus, go to the bottom boundary, but the bottom boundary is a constant, and the derivative of a constant is 0, so there won't be anything over here. So G prime is F. Therefore, G double prime is F prime of X, the slope of F. Okay? So if I'm looking for when G is concave up, I need G double prime to be positive, so I need the slope of F to be positive. Where is the slope of F positive? Well, the slope of F is positive from -4 to -2 and from 2 to 6. So I'm going to say G is concave up on -4 to -2 and 2 to 6 since, and I'm going to say what I did, exactly what I did to figure that out. What did I do? I looked for positive slope of F, you guys. It's what I did. So that's what I'm going to say. Since the slope of F is positive on these intervals, make your sentence coherent, okay? Make it make sense, okay? Now, kids always ask, do you include the boundaries or not include the boundaries? Well, in this problem, they told us on what open intervals. So we definitely don't want to include the boundaries if they ask us for open intervals, okay? Otherwise, I can almost guarantee we will lose that point, all right? Concavity is always open. Concavity is always open. All right, part B. Let P now be this function. Find P prime of 3. Okay? They're just giving me an order, so I'm going to do what they tell me to do. So P of X, they tell me, is G of X times F of X, and I want P prime at 3. So first I'm going to find P prime of X. I need to use the product rule because I have a product. So G prime of X times F of X plus F prime of X times G of X. Now let's find P prime of 3. Okay, I'm putting 3 in for all the X's. G prime of 3. Well, G prime of 3 is F of 3. So F of 3 is -3. So that is -3 times F of 3. Well, it's still -3. Plus F prime of 3. Here's the graph of F. F prime of 3. The derivative of F at 3 is 1, up 1 over 1, times G of 3. Okay, how do we find G of 3? I go to my G function and I'm going to put in 3 for X. So I'm going to come off to the side. G of 3 is the integral from 0 to 3 of F of t dt. How do I find that? Signed area under the curve. So G of 3, I want 0 to 3. 0 to 3. So 0 to 3 will be, remember, you always use the x-axis as a boundary. 0 to 3 is right here. Okay, and I noticed that, they like to do this, I noticed that this sliver of a triangle here is the exact same shape as this sliver of a triangle here. So one is above the x-axis, one is below the x-axis, so those will cancel each other out. I'm left with a piece below the x-axis of area 3.5. So negative 3.5. The finish my thought down there too. Okay. Part C. Find a limit. When I see a limit, I'm fully expecting it to be L'Hopital's. And if I put 2 in for x in the denominator, sure enough, I get 4 minus 4, which is 0. So, I'm going to use L'Hopital's rule. So, to use L'Hopital's rule, I must, if I want full credit, I must split this up into 2 limits. The limit of the top and the limit of the bottom. I already know the limit of the bottom is 0. Now I need the limit of the top. What is the limit as x approaches 2 of g of x? Okay, I know that g is continuous because they told me so up here. So I know that I can find this. I'm guessing it's going to be 0, but I can't not just say it's 0. I need to say what I'm doing to find that. G of 2 is the integral 0 to 2 of f. I'm using the definition that they gave me for g. 0 to 2, 0 to 2. That was those 2 pieces that cancel out. Sure enough, that is 0. The top limit is 0, or the limit of the top is 0, and the limit of the denominator is 0. Therefore, the limit as x approaches 2 of the entire expression is equal to, now I'm using L'Hopital's rule. I usually put a little LH here for L'Hopital's rule. You do not have to do that, but I like to do that so you know when you're looking at my answers what I did to get there. The derivative of the top divided by the derivative of the bottom. No quotient rule. Kids like to use the quotient rule here. I can't get them to use the quotient rule when they should, but then on L'Hopital's rule, for some reason, they like to use the quotient rule. No quotient rule. L'Hopital's rule is not a quotient rule. Just derivative of the top, derivative of the bottom. Okay, now we're going to plug in 2 again. Now when I plug in 2 to the bottom, I do not get a 0. I get 4 minus 2, which is 2. So I know I'm not going to need L'Hopital's again. All right? G prime of 2. Well, G prime of 2. Remember, G prime is f. So G prime of 2 is f of 2, and f of 2 is negative 4. And we're done with part C. Now for part D. Okay. Okay, let me blow my nose real quick. I'll be right back. Alrighty, sorry about that. Okay, find the average rate of change of G. Average rate of change of G. That is change in G over change in X. That's what it is. Okay, on the interval from negative 4 to 2. Alright, so change in G over change in X. So I'm going to have G of 2 minus G of negative 4 over 2 minus negative 4. Alrighty? Now, G of 2 minus G of negative 4, I'm thinking of what is easier. I could go and find, well, you know what, I already found G of 2. I did find G of 2 here. Okay, I found G of 2, so I think I'll just use that. Okay, so G of 2 is 0. Now I need to find G of negative 4, so I'm going to come off to the bottom. I'm showing my work neatly so that it can be read and followed so that I can get credit. G of negative 4 is the integral from 0 to negative 4 of f of t dt. I'm using the definition of G there, which is negative integral negative 4 to 0 of f of t dt, which is negative signed area from negative 4 to 0. Negative 4 to 0. So now I'm over here, and I want negative 4 to 0. Let me get a different little highlighter color. Negative 4 to 0 is this area right here, this pink area. So that's the area that I want, and it's all above the x-axis. All above the x-axis, so it's all going to be positive there. So I'm going to count squares. I'm going to count up squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 whole squares. Okay, what's left is partial squares, right? So right here, this triangle is half of this rectangle. So that triangle is half of this rectangle. The rectangle is 3, so half of it will be 1.5. Up here, this triangle is also half of this rectangle, and half of that rectangle will once again be 1.5. So that is 12 plus 3, or 15 so far. And then I have these two little pieces here. Each of these is a half, so plus 1. So 15 plus 1, 16. So this is negative 16. So this will be a negative 16. And I'm done. Say stop. All right, so I found the average rate of change of G, but there was more to this problem. Does the mean value theorem guarantee a value C between negative 4 and 2 for which G prime of C is equal to that average rate of change? So in essence, is the mean value theorem guaranteed? Well, it's guaranteed as long as G is both continuous and differentiable. I know that G is continuous. Is G differentiable? Okay. So, is G differentiable? Well, do we know anything about G prime? We know that G prime is F, which is continuous. F is continuous. So G prime is continuous. Therefore, G is differentiable. So I'm going to make a statement here. G prime, I'm going to say what I'm thinking. G prime of x is equal to f of x, which is continuous. So G is both differentiable and continuous. Okay? Therefore, the mean value theorem works, is valid, applies, and guarantees. I'm kind of restating guarantees. C in negative 4 to 2 for which G prime equals that value, 16/6. Okay? I should have put a C here. Alrighty. Okay. How was this one scored? Let's look at scoring here. For part A. Well, before they even got to part A, they said 1 point is awarded for saying that G prime is equal to F in any part of the response. Okay, in any part. Now for part A exclusively. Part A was our concave regions, or I'm sorry, intervals, and they just gave 1 point for the answer with reason for that one. That surprised me. Usually they give 2 points for that. Part B. Part B, they did 1 point for the product rule. That was an easy point to get. 1 point for the value of either g of 3 or g prime of 3. So if you got one of those two values, either the 3.5 or the -3. Okay, and then 1 point for the answer with justification. So 3 points for that one, which kind of surprises me. I thought it would only be worth 2, but there you go. Okay, part C, 1 point for the correct usage and showing all of the stuff, correct usage of L'Hôpital's. And then 1 point for the answer. With justification. Okay, so if you did not show these two things, then I don't think you would have gotten either of those 2 points. Part D was worth 2 points. 1 point for the average rate of change. One point for the answer to the second part of that question. I'm just going to say answer with justification. Okay. Every AP exam has this kind of question on it. So you have to know how to do these. So practice, practice, practice.